What happens when the densest star in the universe collides with the most mysterious object known to science? Today, we're diving deep into one of the most extreme cosmic events ever witnessed, a neutron star colliding with a black hole. Here are top 6 mind-blowing facts about a neutron star collision with a black hole. 1. It can tear the star apart. If the black hole isn't too massive, it can tidally disrupt the neutron star, ripping it apart before swallowing it. This process releases incredible amounts of energy. Second, may produce gamma-ray bursts. Some collisions can produce short gamma-ray bursts, the brightest electromagnetic events in the universe. These bursts last less than 2 seconds, but outshine entire galaxies. 3. They forge heavy elements. These collisions can create precious elements like gold, platinum, and uranium, enriching the galaxy with the building blocks of planets and even life. 4. Neutron stars have insane magnetic fields. Before merging, the neutron star's intense magnetic field can interact with the black hole, possibly triggering energetic emissions or unusual phenomena. 5. We can't see the collision directly. Because black holes trap light, we usually can't see the actual collision, but we detect it through gravitational waves and X-ray/gamma-ray bursts. 6. Happens billions of light years away. The neutron star black hole collisions detected so far have happened over 1 billion light years from Earth, yet we can still pick up their signals. A neutron star is the collapsed core of a massive star. So dense a single teaspoon of its matter would weigh billions of tons. It's made almost entirely of neutrons, with gravity so intense, not even atoms can hold their shape. Black holes are regions in space where gravity is so strong, nothing, not even light, can escape. They warp space and time around them, creating an invisible boundary called the event horizon. But how do they collide? When a neutron star and black hole orbit each other, they slowly spiral together, losing energy through gravitational waves. Eventually, boom, they collide. But it's not just a simple swallow and done. Sometimes the black hole rips the neutron star apart in a spectacular tidal disruption before absorbing the debris. Other times, the neutron star is pulled in whole, vanishing in an instant. These collisions send out ripples through the fabric of space-time, gravitational waves.